gone. Okay. Right. So now, that is where I just elaborate the importance of learning Mohs circle and finding principal stress. Okay. So now I'm going to the next page. So now we are going to find principal stresses. Define principal which is we can call stress A and stress B. Now, I believe most of you have done 3CO3. Am I right? Yes or no? Can you remember Mohs circle? Anyone?
Yeah.
Yeah.
Yep.
Yeah.
Some of you. Is it a nightmare?
Yes.
Yeah. Oh shit. Teacher is no good. That's why you're having nightmare. I do apologize. Okay. Don't worry. I will cover more detail in Mohs circle in this lecture. Okay, much more detail. Okay, so I don't want you to worry. Okay, so let me look into. Okay, so let me get rid of not important part of the circle. Don't be afraid of Mohs circle. Okay. It's easier using the technique I teach you in Mohs circle than the textbook. Okay, but anyway, so the first thing we have to find now, we are going to find the principal stresses. Okay, I'm telling you, my course is not as bad as Dr. Judd's heat transfer. Okay, that one, it's not it's a life shortening experience. Okay, right. So from here, you can see that we are going to find stress A and stress B. Okay, so we're going to find stress A. Okay, so first thing we have to find is the center of circle. Same thing like what I taught you guys in 3C. Okay, no change. Okay, so this one is in plane. Later on, I'll explain to you what do you mean by in plane. So this is equal to stress X plus by stress Y divided by 2. So you have a equation looking, if you look at last week's notes, okay, there are all the constants over there, refer to them. So this is equal to 2500 C minus by 72,000. And this is divided by 2 pi C cube. And to remind you guys, C is the radius of the circle, of the shaft. Oh, shoot. Okay. So from here, we also so what we are trying to find down here now is we are trying to identify where is the radius of the circle. Sorry, the average center of the circle. So over here, this is our stress average. Okay. Then after that, we are going to find the radius of the circle. Okay. So the radius of the circle is also our maximum shear. Okay. So this will be equal to, so get the whole thing. All right. So it's simple math. Okay. So you want to find the radius of the circle. let me see. Okay. So the distance, let me use a different color. The distance from here, that is the radius, right? So what we want to do is find this distance, right, which is our shear, and then find this distance, which is our normal stress, and these two happen to be the same, right? So for now, from here, we are just going to plug in the formula. So the normal stress is this one. Okay, so over here, square, and then the shear is 5 pi 200 over pi c cube, and the whole thing square. Okay. So to find the principal stress, it will be equal to stress average plus by minus tau max. Okay. So we have to ensure that stress A and stress V is equal to stress average equal plus or minus maximum shear. Okay. And we have to apply this rule. Okay. So the maximum shearing stress criteria that we're going to use, that the question to us to use, by the way. Okay, so we have to ensure that stress A minus stress B, right, will be equal to twice shear stress U, which is equal to 2 times 50 times 10 to the power 3. This will be equal to 100 times 10 to the power 3 psi. Okay, so from here, all we need to do now is to write down stress A minus by stress V. So stress A is equal to, so for me, I'm really lucky. I can just copy and paste. Okay, so this is, right, so this is the first one, stress A, plus, yeah, sorry, you find my voice not very clear now because the nerve is not working, okay? But bear with me, okay? Okay. So you have this term, this is your stress A, okay? Then we minus, all right, we minus the same thing. Not really the same, but then you minus the same thing. So you close a bracket down here. Okay, so this one, the internal, you change to a minus sign because of this, okay? Stress A and B is stress A average plus minus the shear stress, okay? So from here, the only thing that will happen now is you will have this function, okay? You have this, so these two can be taken out, right? So minus become plus. So you have stress A minus stress B is equal to twice the entire term over here. Okay. And then this whole term will be equal to 100 times 10 to the power 3, right? So from here, you need to find C. Okay, from here you just need to find C. So to find C, so to find C is real straightforward. So you have to manipulate the equation. So the equation you get is 6 power 6 plus by 63.3257 times 10 minus 6 C squared plus by 3.6476 times 10 to the power minus 3 C, and then we're going to minus this by 0.176 is equal to 0. So now we have to solve this equation. And to solve this equation, there in any work that you're doing, okay, we have to solve this equation, okay. So we are going to use Excel. I don't know, have I shown you guys this regarding GoSig? Okay, so you just, I know there are other software available online, Wolfram Alpha, CatRam Alpha, or whatever. But let's say you don't have internet access, you can use this method, okay? I think I showed you guys before, but I'll still do it. So you're going to find, oh, wait. Can you see my Excel? Yes, right?
Yes.
Yep. If we didn't take 3C, should we do extra work outside? No, don't. Okay, I will make sure I will gear you up. Okay, I'll gear you up. So you just put C. So C is your the oh god, radius of your circle. Okay. So this is C. So now I put an arbitrary number. Okay, 0.5 inch. Then I type in the equation. So the equation is C, right? Power of 6 plus by 63.3257 e to minus 6 multiplied by power of 2. Yeah, something is squishy. Then plus 3.6476 e power minus 3 multiplied by C minus by 0.176. So now the value is not equal to 0. Okay, so don't you guys like do this? Okay, hold on. Don't do this. Okay, I put 0.1, 0.001. Okay, don't do this. Okay, so there's a function over here. I hope you can see. So it's under data, right? Is it? Yeah. It's so if you click data, then you click what if. There is a GoSig function. Okay. So oh god, this is too small. Can you see? Right? I think you can barely see. So the set cell is this value over here. Okay, this is a set cell. You set it to be equal to 0. Okay, and then you change the radius of the circle, and you just put okay. Okay, so there you go. The right diameter radius of the shaft is equal to 0.746597 inches. I'll do it again, okay? So I'll show you. So let's say now we put 1 or we put 5 inches, okay? Then you go to what if, GoSig, okay? set cell is this cell you want to set it be equal to 0, and then by changing this the 5 the 5 that I just clicked, and you just wait for the computer. So okay, so now the value is there's some zeroing error. Okay, so it's equal to 0.747. Okay, so we realize here that C is equal to 0. Oh, hold on. Right, 0.747. Let me be sure. Yep. Okay, inches. Right, and this is based on the stress U of 100 psi or ksi, and shear U of 50 ksi. Okay, so what I show you from the introduction to now, okay, you'll be a total of 8 weeks of lecture. Okay, then you are able to select or design structure properly. Okay, it's the integration. Okay, it's the integration. So if you look at here, we're going to do both term tests 1 and 2. Right, you have to be very capable in analyzing the stresses and how to combine them. Then week 9, week 10, week 11, week 12. Over here, we'll be dealing with buckling. Okay, so buckling is for structures that are very slender. Okay, so we call this a slender structure. And you have a high normal load. How do you design your structure? Oh, sorry. Okay, how do you design your structure? Week 9 and week 10 is design of beams for deflection. Okay, so down here, Dr. Koshi have taught maybe 5% of it is to using integration method to calculate the shear force, bending moment, but we're going to go further. Okay, we're going to look into calculating the deflection and the slope of the deflection. Okay, other than that, anyone, any question? Anyone? Okay, if no, I'm going to stop lecture here. Remember, tomorrow, okay, tomorrow we are going to have lecture at 9:30. Don't go yet. I will stop recording. Oh,